Hey, my name is Andrew Couch. I'm a business analytics student at University of Iowa, and today I'm just gonna go over the TidyTuesday series or data set. So basically, every week TidyTuesday will release a data set for you to analyze and make charts on. So I thought it'd be interesting to just do a video of my process when I'm looking at a data set and how I do a basic exploratory data analysis. So we'll go to the most recent data set, which is food's carbon footprint. We'll look at that, and then they give you a way to load in the data, which is this one little liner over here. And we'll just exit out of there, pull up our studio. I'll do this thing. I'll do this analysis in R Markdown. So I'll do Tidy Tuesday CO2 emissions, and I'll do it from a template, which is a GitHub template. Oops. Tidy Tuesday CO2 emissions. All right, sweet. Remove that junk. We'll do the actually I'll do it on a new chunk. So creating chunks is Control Alt I, and we'll first load in the Tidyverse. Okay, sweet. And then we'll load in the data set. Okay, so what's kind of cool about the Tidy Tuesday project is that they basically just give you a wider range of data sets. So for this one, we'll just kind of look at it. It appears that there's a country, a category for each country, its consumption and CO2 emission. Okay, so let's look at just how many countries there are. So we'll do count country. Okay, so we have about 130 rows of countries, and for each country, there's 11 other things that are with it. So I'm gonna guess that it is food category, right? Okay, we'll just kind of go through that. All right, so each country basically has its relative food category, and then I guess its respective CO2 and consumption of that product. So it gives you the consumption of pork with its relative CO2 emission. All right, cool. Okay. One thing that you should probably always do that is a little bit easier, just do a summary function, right? Doesn't really tell us a lot about that, but it does give us some summary statistics of consumption in CO2 emissions. So I'm going to comment just viewing the basic summary of the data set. What is it? 130 countries, right? Many countries and 11 food categories. Dope. All right, so let's just do a visualization of that then. So I'm just going to gather, which is we'll just gather the consumption CO2 emission, and I just want like a holistic approach, so we won't do it by country. So we'll say the main thing is the feature with its relative value, and we'll ignore country, and actually, yeah, we'll ignore country and minus food category. So now we just have it in a more tidy format. And we'll plot this out where, let's see here. Yeah, we'll just do a box plot of it. So color equals feature box plot. And I'm going to do a facet wrap so we can see each box plot individually, just so nothing crazy happens. Okay, so right here, it's kind of all over the place. It's pretty bad, and you can't really understand this data set right now, this chart. And that's pretty normal when you're dealing with like countries, because all countries have like different population sizes. stuff like that. So normally you're gonna have to do like a log 10 transformation. Okay, so right there, it's pretty easy to look at. Honestly, one thing that's kind of interesting is it kind of seems relative, where CO2 emission is basically equal to the amount of consumption, which kind of makes sense. Additionally, if you see how right here it's 1E plus O3, that's in scientific notations. So we can remove that by doing the SciPen thing, and I'll put it back to that. So okay, so there are a little bit different scales, right? So that makes it way easier. And in fact, if we wanted to fix the scales, we can see how it's a little bit different, right? The distributions are a little bit different. Cool. Okay. So distributions of CO2 and consumption are not as proportional as I would imagine. Okay. And what's cool about this is we'll actually just kind of do a little bit more detailed of a plot. And one cool thing that I like to add is a geom jitter, where the alpha is 0.4. Let's go. That adds. Okay, we may have to do that. So that way we can kind of see the basic density distribution of it, right? Which shows the same story of the box plot, but it's a little bit more interesting, I think, because you can see how the outliers of this one, of the first graph, is you kind of just think, oh, it's just a few of them, when in reality it's actually a decent amount. It's not just like a single digit of outliers. Okay, that's kind of cool. So let's see. Actually, I have one question on it. Let's go back to TidyTuesday. And I actually should probably look at the data dictionary first. So what is their actual consumption and emission? So consumption is kilogram per person per year. So how much each person, how many kilograms of food a person eats every year, whereas how many kilograms of CO2 is produced per year. Okay, that's kind of cool. So one thing that I see is similar scales, right? So we can kind of say kilogram per person, and then kilograms of CO2 produced. Okay, so I'm gonna exit out of that. I'll write down something. So consumption equals kilograms ate by each person every year, and then CO2 emission equals kilograms kg of CO2 produced per person by each. I'll do by each person every year. Solid. So one thing I would think is, okay, if we can just kind of reformat this question into like almost an efficiency question, so we can just do some basic algebra, remove year. So I want to see like which countries actually have like an efficient consumption process, where for every CO2, for every kg of CO2 emitted, how many kilograms of food do they eat? And you can kind of frame it in different, or like, honestly, it's better with kilograms of kilograms of food eaten produces how many kilograms of CO2. That's probably better to understand. Although these actually questions kind of seem like the same question. However, they're actually a little bit different, right? So like kilograms of food eaten and produce how many kilograms of CO2. One thing that would be interesting for this is, I bet countries that are richer are going to be eating more food, which will lead to more inefficient production of CO2. However, this one, for how efficient each food is eaten, is probably produced by more agrarian people, but they should be a little pretty similar. So we'll just do something that's a little bit more understandable. So we'll do every kilograms of food eaten produces how many CO2, just to keep it normal. So we'll do that. Okay. So we'll kind of suck that bad boy. Kind of make sure we'll look at that, and we'll do mutate, and we'll do like food CO2 per food, right? CO2 per food, which is just CO2 emission divided by consumption. What the hell? What am I looking at? CO2 oh, it's 2 M's. Dope. Okay. And one thing I would be interested in is like, I bet food category plays a huge role in that, right? So we'll do a by food category, and we'll just like summarize it and say mean equals mean CO2 per food, and we'll do average CO2 per food, right? Okay. NaN. Oh, we have to do a drop Na thing. We'll do a NaN. What the? What's going on over there? Okay, so there's some NAs. That's kind of weird. Count is on NA. Oops. Is on NA, and we'll do summit. Huh. That's weird. What's going on? Oh, maybe, let's see here. Filter where consumption equals 0. Oh, okay, there we go. That's what? Huh. Oh, that makes sense. Okay, so obviously in India they're not going to eat pork, I guess, because that's a religious affiliation. Okay, so what we're gonna have to do actually is filter consumption does not equal 0. Whoop. Okay. Totally forgot about that. So that way we'll just do category y equals average CO2 per food, and let's do a geom call. Let's see what that looks like. Huh. That's kind of weird. And I'll do a reorder by average CO2 per food. Okay. And, equals. Okay. So just did some basic formatting. I'll do I'm a fan of flipping box plots or bar charts, and then since we don't really need the legend, we can see that we can just remove that since it's all by we already have the labels. Sweet. Okay, so this kind of makes sense, right? But one thing that I think is kind of weird, right, is that usually when people say about how inefficient food is, we always talk about beef, especially in America. When in reality, I guess lamb and goat is a pretty inefficient food group. I think, obviously, I guess the reason why we don't really talk about lamb and goat is no one really eats lamb and goat in America, and especially where I'm at in the Midwest. But it's definitely pretty interesting how there's a huge discrepancy between like lamb, goat, and beef with the remainder, right? Like on a CO2 basis, it's just like tenfold. That's insane. Kind of makes you reevaluate how you should be eating. And additionally, you can see how like rice is a little bit less efficient than poultry and eggs. So that's kind of weird. Like poultry rice is more inefficient than wheat. Kind of cool. Okay. So let's just write down what we observed, right? Okay, we'll say lamb and goat is inefficient and should be avoided. Same with beef, but I'm gonna say mostly everyone knows this. And then we'll say also, rice is more inefficient than wheat. That's kind of weird. Okay. Cool. So given these categories, let's kind of look at these distributions of like consumption. And also, let's just do a kind of a facet style of where I want to see the distributions of consumption with all these food categories and also the CO2 emissions. And maybe let's see if there's like some kind of relationship with that. So let's do that. Just let's do select everything besides country. And just do a basic gather. I think you can actually do a pivot. Let me do this other one. Normally I use the gather and spread function, but let's do like a pivot wider, and then oh god, I don't want to do that. No, I'm gonna try it. Consumption and CO2 emission, and I'll do like what values from, and then consumption and CO2 emission. Let's see if that works. Oh god, that didn't work. Oh my god, that didn't work. Oh, it's because I did pivot longer. Oh god. Why am I doing this? This is names too. Names are values too. Okay, I'm not doing this. I don't really know. But yeah, the pivot wider and pivot longer are definitely pretty useful if you actually know what you're doing, but I do not know what I'm doing. Equals value minus food categories. Oops. Value. What the? Food category. Oh my god, what the? Okay. There we go, Jesus. Alright, and we'll do another category, y equals value. We'll do color equals food category. Go box plot. Let's do a facet wrap. And then we'll do, we want to do by feature. You know what, we'll do a fixed scale. And I already know we don't want to see up as a legend. So we'll say legend position equals none. Again, we still have to do the scale y log 10. Okay, so we see some cool stuff. I'll do another chord flip too, because why not? Okay, cool. It does look pretty similar. Let's look at each distribution one by one. And we have to note that our axes, I guess, are fixed to some point. Cool. So let's look at the ones that we were first starting at. So let's look at lamb and goat. So lamb and goat are right here. We can see how right? The median value is between zero point 0.1 and 10 in a logarithmic state. So, I don't know what that value is yet, but it's easy to compare how this median is much higher than the other median. It really shows how, like, even though it's not being consumed as much, it still is emitting a lot of CO2 emissions. Same with beef, right? Beef, the median consumption is about 10 kilograms per person. However, its production is almost reaching towards like 100 to probably like 4 to 500 kilograms of CO2 emission per person. Cool. I think one thing that'd be kind of interesting is just kind of look at it like an efficiency plot. So let's do like where we do like consumption and CO2 emissions as like an X and a Y axis, where I would say CO2 is a resulting variable. So we'll put CO2 emission on the Y axis and the consumption on the X axis. Okay, that makes sense. Okay, and then maybe we could. Yeah, I'm gonna do that. We'll do like we'll have like the food categories still be the color, and maybe this will tell an even easier story to understand, or at least a better story, right? CO2. Oh my god, that's why it's emission color equals food category. And we'll do a geom point. We might have to do an alpha, but I'm not sure. And then we'll do a geom geom ab line, right? And we'll say the slope is 1. And this is like total efficiency, where it's completely impractical, because like just on a physical standpoint, where if you consume something, there's gonna be a lot of wasted energy too. But this is assuming that like whatever calories go in, the exact calories come out, and it's like a perfectly efficient thing. Oh, oops. Okay. So we can see something kind of cool, right? However, again, with using real world data, usually most data is real world on a large scale is, I guess, normal, but it's mostly log normal, right? So you can see how that is pretty cool. That's pretty interesting. Which makes sense, because honestly, we probably wouldn't need to find every country's food consumption, but we can see how it's pretty straight, and this data kind of makes sense on an efficiency standpoint, how each food category, no matter how much consumed and stuff, will emit basically the same rate of CO2 emission, which makes complete sense. And it'd be honestly weird if we didn't see anything crazy. But I think even then, this is pretty cool. However, I'm actually going to do a group by category. Oops. Food category. Because there is a lot of like junk, right? We don't need this actually. Consumption. So we'll just do the averages, but CO2. Oops. Consumption. Oh. Come on. Consumption. No, what's going on here? Object consumption. Oh, oops. See, that's why. Okay. And this tells a fantastic story, right? We can see how basically these residuals are completely off, right? How we have beef right here, it's super high, and eggs, right? Where eggs are kind of right on the line. They're pretty efficient. Dope. That's kind of a cool thing. Okay. In fact, I could even just do like a basic residual thing too if I really wanted to. And I don't know, we could do that. Why not? Okay. We'll add some residuals. And this is okay. And then we'll residuals. And that residual is going to be CO2. It's going to be, what is it? CO2 emission minus consumption, right? Hopefully I didn't get that confused. Yeah, there we go. And then we'll plot that bad boy into ggplot. And with ggplot, we'll add the points right there. We'll also do a geom segment xn equals, what is it? What was our consumption? Yn equals consumption. Oh, I guess I didn't really need to do that. Okay. And x equals consumption, and y equals CO2. CO2. And that's pretty interesting. All right, there we go. We didn't actually need to do the residuals, but you know, if we wanted to plot out the residuals on like a, I don't know, like a normal kind of like do a residual plot, we could do that too. But you can see right here, the difference between it is staggering, especially when you have you have beef and you have lamb right there, and they're just huge. And I guess you can have, I guess CO2 emission isn't a perfect thing of efficiency, but it's still something of like proportional waste on its kilogram level, because you can see how what soybeans and wheat are below the line, right? So that's kind of cool. Okay. Now, what else do I want to ask about this question? Well, let's find just the most let's find the top consumers of each food category. This is something where you probably just don't even, you probably don't need to find the you probably don't need to find the like create a plot or anything, because this thing where if you're gonna do a top end and a bottom end, it kind of serves better as just like a table, I would say. So let's just do that. We'll say country, and we'll say consumption, right? N equals 5. Milk and cheese, and then we'll actually we'll do a group by and then food category. That's pretty funny how these countries consume a ton of cheese, I guess. Cool. Range by we'll do consumption. Oops. Cool. So we can see how like just on a, I guess we should do a food category too. Okay, so beef, Argentina, Brazil, those make sense, right? And we can see, I want to go back to the milk and cheese thing. Okay, right there. Finland consumes a lot of cheese, I guess. Does that make sense? Because I would think Switzerland like France and stuff would consume a lot of cheese. I guess it includes milk, so that's a little bit different. Okay, and then pork, Hong Kong, China. Okay, that kind of makes sense. Austria, poultry, Israel. Okay. So one thing that would be interesting is, okay, so we have the top 5. So top 5 consumers of each food category. One thing I'd be interested in is like, okay, so given all these like top 5 kind of consumers or of these foods, let's find like how many countries are in it twice or multiple times, right? How many countries are like the consumers of multiple products? You know, they're on the top end of all these other food categories. So we'll just do a count country. Oops. Oh, I have to do an ungroup. Count country. And boom. Right? Oh, and we have to do sort equals true. Okay. So now we have these guys. And this is something where I would honestly want to maybe put on a plot, but we're not sure yet. We can see how most of these countries on consumption level, most of them are like ones, right? In fact, yeah, most of them are ones. However, there are some people who are on it 3 times and then 2 times. There's only one that's on 3 times, and it's Hong Kong and China. And honestly, it's kind of weird how I don't see America or the United States in it, right? Maybe the United States doesn't consume as much food, or maybe they just consume a lot of food, but in different categories where they're kind of like being spread too thin on it. But okay, we'll just write in countries that appear more than once in the top 5 consumers by food category. Okay, and we'll do obviously a filter and does not equal 0. Boom. Does not equal. Oops. 1. Cool. Okay. So one thing with the TidyTuesday thing is that they have different, you know, we have our foods, but we don't actually have like kind of like these categories of foods, right? So when we look at it, like we have animal and non-animal products. Let's compare that, right? That's kind of a cool idea. And obviously, I think there is kind of implicit like, oh, non-animal products are definitely more efficient or less harmful to the environment than animal products. But like, I'm kind of curious on like how much are they better for the environment. So let's do that. And I'm pretty familiar with food, so I think I can just kind of manually do it. But let's see what we're doing here, and we'll just do select food category. We'll do unique, I guess. Okay. Nuts. Okay. So we'll probably just create a. I'm trying to figure out the best way to do it. I think the smartest way is just do an in, an inclusion, and an or statement. So let's just find the ones with the minority class, and I believe that would be non-animal products. So we'll do wheat and wheat products, rice, soybeans. Okay, and then nuts, ink, peanut butter. Okay. Oops. And let's do mutate. Let's do what's a good thing for food category? We'll say vegan. Okay, equals if else. Okay. Food category is in, boom, this, then we'll say non-animal product, else animal product. Let's see here. Does that make sense? Okay. And then I think one way to just kind of make sure nothing's too crazy is we'll do like food category. We'll just do a count food category by vegan, just to like do a make sure nothing crazy is going on, right? So beef shouldn't have like animal product or non-animal product, and we can kind of sort through it where rice, soybeans, nuts. Okay, so there we go. So we got it. And then I'm just gonna select, since we just need consumption, CO2 emission, vegan. Okay, solid. And then honestly, one thing that I totally forgot was to do a correlation between consumption and CO2 emission, right? Oops. Structure num. Okay. Oh. Dope. So we have a correlation. Okay, so it's actually not as correlated as we would think it is. Okay, that's not really what we wanted to care about, but okay. Again, this is something where maybe we should do a let's do a Ttest, right? So let's do a group. Actually, we'll do a gather first. Key equals type value equals value minus vegan. Boom. And then we'll do group by type. And then we'll do a pivot wider. Names from type, values from. There we go. Okay. And then we'll do nest. Actually, we don't even need that. Since we're just doing a Ttest. Okay, let's do a Ttest between v animal and non-animal for consumption and CO2 emission. We'll put in the broom package. Boom. Dope. Okay. And we'll do a Ttest. Oops. I want to look at the thing. So we'll do the do function, which is kind of like the mutate function for broom. And we'll say value to vegan data equals dot. Oh, must be 2 dane frames. Oops. We'll do test. All right, test. So we just ran to Ttest, and we'll just do unnest test. What is going on here? What? Ruh-roh. What the hell's going on? Vegan. What's going on here? Mutate type equals dot factor type. Oh, that's why they're not factored. Okay. Vegan equals as dot factor vegan. Hopefully they'll still work now. Group by type. Do Ttest equals T.test. Vegan to value oops. Oh God, what the hell? Okay. Oh. Oops. Test equals t.test value to vegan data equals dot tidy test. There we go. There we go. Jesus. Okay. So now we have a tidied t-test. I totally forgot the tidy part. That's ridiculous. So what are we looking at? So CO2 emission is statistically significant, right? We got that. However, our consumption is not. So people may be consuming relatively the same amount of vegan and non-vegan products. So that's pretty cool. And just to do a basic test for that, just do a basic plot for it, I guess, is geom column plus geom h line y-intercept equals 0.05, right? Crazy. Yeah. So you can see how CO2 emissions is very statistically significant. I don't even think it'll like me when I do a scale log 10. Yeah, so it's very, very significant. That's not a good plot. It's easier to just do that. Okay. So let's see here. What else should we ask for this? Let's look at the countries actually. Let's look at that again. So select country unique, and then so we got a decent amount of countries. Jeez, 130. I'm curious on what I would want to do with this though. Let's see. Yeah, let's do most popular consumption, right? So we'll do top N. Actually, we'll do a group by country. Top N consumption N equals 1. Okay. Wow. And you know what? Let's do a mutate from our previous thing. Let's see if most of these people are eating a lot of vegan foods or non-animal foods. Okay, no, they're all animal products. And then we'll do a count vegan. Oh, ungroup count vegan. Okay, 90-40. So it's not too bad. In fact, let's find food categories, because what are the most popular food categories too? Okay, we just do a sort. So milk and cheese, they that's the most popular thing. That's the animal product, is milk and cheese. And honestly, milk and cheese, like when I'm looking at this, like, one weird thing is fish. One country's most eaten product is fish. I'm gonna guess that's an Asian country. But if you look at milk, rice, and wheat products, if we look at our previous chart that we made, like milk, yeah, milk is a little inefficient, but milk and rice are, pretty. They don't really contribute a lot to CO2 at least. And then wheat products are pretty good. So maybe if I was someone who I guess was trying to reduce CO2 emissions through consuming habits of food, I would probably try to promote just eating more wheats, just obviously more grains, basically. Which, if you think about, like, Asian food is mostly just like rice, fish, not really a lot of milk or wheat, but maybe an Asian diet would be kind of nice too. It's kind of interesting, especially if you think about it. Vegans really do have a lot of options too, because they can kind of just eat whatever they want for vegan and non-vegan consumption of CO2. Cool. Okay. Let's look at this again. All right, let's look at. Did we look at this already? Let me look at it. Yeah, so we did look at consumptions for all of these things, but maybe we should look at it at a bigger picture than just box plots. Maybe we should do some density things. Right? Might as well make it. Might as well. So we'll just do the value equals value minus country minus food category. Actually, you know what we'll do more vegan stuff. That's kind of cool. Right, and then we'll do minus vegan. Right, so we have our thing. And actually we don't need country. And yeah, we don't need country. So let's look at dplyr x equals value. Color, we'll do color equals food category. Actually, I'm trying to think of how I would do this. Because what I'm thinking about doing is maybe doing like let's go back here. Maybe it just like have a kind of a distribution chart of each food category on the, I guess, the y-axis and its distribution. And then also show its kind of side distributions of like, okay, here's pork. Oh, I guess that doesn't make any sense. No, we'll just do vegan distributions. Yeah, we'll do that. So ggplot AS x equals value. We'll do color equals vegan. Geom density. Look at that. Maybe we'll have to do fill too. Fill. Oh god. Whoa, what the hell is going on? Oh, that's why. Scale log 10. So that's pretty interesting, actually. 0.3. Right? In fact, let's do a facet. Oops. Feature. Plus facet wrap. Feature scales equals. Let's just do that. Oh, oops. So that way we have what is it? Do I do n row? 2. There we go. So there we go. We have what we see here is actually like CO2 emissions are definitely their mean and or whatever is definitely to the left of animal products. Animal products definitely produce more CO2, and then just on a consumption basis, we actually do consume a decent amount. However, on the majority, people do consume a lot. of animal products. So like some countries will actually consume a decent amount of non-animal products. However, the majority of countries do consume still just a lot. And it's something where we would probably want it to be inverse, where we'd want it to have a lot of people eating non-animal products, and then just some countries where they eat a lot of animal products. But it would be kind of the minority, where majority of people or majority of countries would be eating non-animal. So if you just inverted that, that's what we would probably want to see. Okay, right on. Yeah, I think that's kind of it for what I wanted to do right now for this data set. I think this is like, Jesus, probably like an hour-long video, like a 50-minute video. But yeah, this is basically just a preliminary analysis. Honestly, this data set just isn't that large. It really isn't that big, and there's only 2 numerical data variables and some categorical ones. So it's a pretty simple data set that I think actually you could kind of dip your toes in. So I'm going to just save this thing. I'm going to save this thing on, where's TidyTuesday? Let's do oops. So I'm going to save this, and it's TidyTuesday CO2 Emissions. I'm going to save this thing, and I'm going to knit it to a kind of a GitHub document to post on my Ruby. But yeah, that's basically it. Let's see here. I think that's all I really needed to do. So let's see here. Yeah, let's see here. Oops. So yeah, if you want, I'm probably going to post more videos of me just analyzing this. This is my first time doing this, so I definitely meandered a lot, and I might edit some of it out, but hopefully you learned something, and I'll probably see you next week.